Alright, so the answers to these are here, and yeah, we would just use the properties, right? So we would say that this side's equal to that side, and that side's equal to that side. Those would be our two equations. This one here, we would set these two angles equal to each other. And then once we have those, then we could go ahead and solve for x, because then we have, once you find y, you can find what this angle measure is and what that angle measure is. And then we could go ahead and find x. So same thing over here, right? We know the diagonals bisect each other, so we set this expression equal to that expression equal to that expression, and so on, right? Down here we would need to use the properties that we know about parallel lines cut by a transversal, right, in order to find the values of b. So here we're trying to find, b, we would set these two equal to each other, solve for b. R, S, T, we would find, because we know that this angle BRU is congruent to BTS, so this would be 30 degrees here. And then we would use, the triangle angle sum theorem, so 180, or this angle plus that angle is equal to 180, and then we would solve for angle RST, which is 125. Right? So let's go ahead and move on to the new material. It's the next page. We have this parallelogram ABCD, and we need to find the value of each variable. We need to find the coordinates of the intersection of the diagonals. Okay, so the first step here is to graph it. So we're going to graph A is going to be -4, 1, 2, 3, 4. +3 is up here. And then we got 2, 3 is over here. And then we got -1, -2 is there. And then we got -7, 1, 2, 3, 4, 5, 6, 7. -2 is there. Okay, so this is going to be A, B, C, D, like so. I'll go ahead and draw my lines like that. And then the problem is to find the intersection of the diagonals, right? So we're going to go ahead and draw our diagonals like so and like so. And so you can see here that it's by graphing it, it's impossible to find the exact coordinate of the diagonals, right? Because it's in between the units. So the method we're going to use here is, we know that this segment is congruent to this segment because of the theorem that we just learned about, right? That diagonals bisect each other. And we also know that this segment is congruent to that segment. So here, these two are congruent, and those two are congruent. So if those are congruent, then that means the intersection here would be the midpoint of A and C. The midpoint of A and C, right? So remember, the midpoint of A and C is equal to x1 plus x2 over 2, and y1 plus y2 over 2. All right. So yeah, let's go ahead and do that. Right, let's go ahead and plug in the coordinates of the intersection of the diagonals. Okay, so then we got A and C. Those are those 2 points. So we'll do -4 plus -1, over 2. And then we'll do 3 plus -2 over 2, like so. Right? And then what is that equal to? It's -5 over 2, and then 1 over 2. So then I'm going to simplify that to a mixed number. So it's going to be -2 1/2, and then 1/2. And if we go ahead and confirm on our graph, we could see that the x is -1, 2 1/2, and our y is 1/2. So this works out. Right? So anyhow, that's how we're going to go ahead and solve these problems down here, number 10 through 12. I'll go ahead and show the answers in the next video.